Hi everyone. In this video we'll go through topic on application of derivatives. The first topic would be introduction and finding derivatives as rate measure. That is, we can find the velocity, acceleration and surface area using derivatives. Application of derivatives. What is derivative? Derivative is nothing but rate of change of one variable with respect to another. For example, we have one particle. It is moving from one point to another point, say point A to point B. The movement of the particle from point A to point B for a given time, say 1 second or 5 seconds, right? How much of distance, how much of movement is happening from one point to another point given a specific time, that rate of change can be measured using differentiation. This particular rate of change is required in different industries, in different fields, such as biology, economics, physics, chemistry. For example, in biology, for a certain specific amount of time, you want to figure out the amount of bacterial growth. Similarly, in economics, you want to find the increase in the revenue, or you want to find the increase in the profit given a certain amount of revenue. Or in physics, right, you want to determine the movement of a particular object from one point to another point given a specific time. So like this, in different areas, you can find out derivatives so that we can find the rate of change of one variable with respect to another. For example, velocity is nothing but rate of change of displacement with respect to time. From one position to another position, the movement is called as displacement. So now if you have to figure out the movement from point A to point B with specific to certain time, then we call it as velocity. So displacement, say you denote it as S, right? So what is rate of change of displacement? It is nothing but ds by dt, right, with respect to time. So it is ds by dt. Similarly, what is acceleration? The formula for acceleration is nothing but rate of change of velocity with respect to time. Rate of change of velocity with respect to time is acceleration. Now what is velocity? Rate of change of velocity is nothing but dv by dt, right? dv by dt. We know v here, right? v is equal to ds by dt. Instead of v, we'll put ds by dt. It will be like this, right? Instead of v, we put ds by dt, which is nothing but double differentiation, d and d, double differentiation. So it is d square by dt square. It's double differentiation. So that's what we have told here. If you double differentiate s, you'll get acceleration, or if you differentiate velocity once, you will get acceleration. Another example, say we have area of circle. What is area of circle? It's pi r square, right? Now if you have to find the rate of change of area, how is the area of circle changing, right? How is the area of circle changing with respect to radius? Simple. Say area of circle is a and radius is r. So rate of change would be dA by dr. Rate of change would be change in area with respect to change in radius. Now let's take one simple example. The displacement s of a particle at a time t is given by this particular equation, right? This particular equation. This equation is for displacement. S is nothing but displacement. Find the velocity and acceleration when t is equal to 2 seconds. That is, when time is equal to 2 seconds, we need to find out the velocity and acceleration. Now velocity formula we'll have to remember. What is velocity? Rate of change of displacement with respect to time. So it is nothing but ds by dt. What is s here? S is this particular equation, right? Now you differentiate this equation, right? Once you differentiate, what is derivative of 4t cube? Put 4 outside. T cube is nothing but, you'll have to use the formula of d by dx of x to the power n. Derivative of x to the power n is n into x to the power n minus 1, right? So t cube, derivative of t cube is 3 into t 3 minus 1, 3 minus 1, which is 3t square. So that's what we have put here, 3t square, and then we have 4 into 3 into t square. Similarly, derivative of 6t square is 6, t square is 2t. This is the derivative. Then derivative of t is 1. Derivative of constant or a number is 0. So we get, this is the derivative. This is what is velocity with respect to time. Now we'll have to figure out when t is equal to 2 seconds. What is the velocity when t is equal to 2 seconds? So instead of t, we put 2 seconds, and you get, when you calculate, you'll get 25 units. Now next we'll have to find acceleration. Find the acceleration. What is formula for acceleration? Acceleration is nothing but dv by dt, right? That is, we have got v here. We have got v here, right? Now you differentiate this again. When you differentiate this again, you will get acceleration. Okay, nothing but double differentiation of displacement, double differentiation of this equation, or you differentiate this velocity once. So if I differentiate velocity, so what did I get? This is the first derivative, first order derivative, right? So you substitute this 12t square minus 12t plus 1 here, differentiate this again, and you will get acceleration, which is 24t minus 12. Now we have to find acceleration when t is equal to 2 seconds. So substitute t as 2 seconds and you will get acceleration as 36 units. Now let's take this another problem. The radius of a circular plate is increasing at the rate of 2 by 3 pi centimeter per second. Find the rate of change of area when the radius is 6 centimeter. So first, radius of a circular plate is increasing at the rate of 2 by 3 pi. So radius of a circular plate, so r, is increasing at the rate of 2 by 3 pi second. That means it is with respect to second, that is with respect to time, right? It is increasing, which means it is derivative. There is a change, right? There is a change. So because it's increasing, so derivative dr by dt. Radius is increasing at this particular rate. So dr by dt, this is radius increasing with respect to time. And what is dr by dt? 2 by 3 pi centimeter per second. Now what next? Find the rate of change of area. You have to find the rate of change of area. Say area is equal to A. You need to find the rate of change of area with respect to time actually. Okay, time is not there in the question, but you have to find it with respect to time. So nothing but you have to find dA by dt. This is what we need to find. When the radius is 6 centimeters. When radius is 6 centimeter. So let's first find dA by dt. What is area formula? We'll have to remember the area formula. What is area of a circle? Area of a circle is pi r square. This is the formula. So d by dt of area. What is area? Pi r square. This formula we'll have to remember. Now let's differentiate this. What is derivative of pi? Pi is a constant. Pi is a number. So just leave it like that. What is derivative of r square? R square is 2 into r. Now we have to find the derivative with respect to t, but t is not here, it is r. If you are differentiating a term, it should be with respect to this particular denominator, but here we are differentiating r, right? But denominator is t. In that case, we'll have to put dr by dt. Dr by dt is given here. Dr by dt is 2 by 3 pi. Let's substitute. So pi into 2 into r, 2 by 3 pi. Pi and pi will get cancelled. I'll get 4 by 3 r. And the unit is centimeter square per second. Because area is always centimeter square, right? And time is in seconds. So centimeter square per second. Now we'll have to find when the radius is 6 centimeter. So now we'll substitute. Radius is 6 centimeter. So we'll substitute here. So 4 by 3 into 6, which is nothing but 8 centimeter square per second. So this is the answer. Now let's take another example. An edge of a variable cube is increasing at the rate of 10 centimeter per second. How fast is the volume and its surface area increasing when the edge is 5 centimeter long? So this is a cube. Now edge is nothing but the side, right? These are all the edges. Edge is nothing but side. Now first we need to know the formula. We need to find the volume. We need to find the surface area. We need to know the volume and surface area. So what is the volume formula? Volume of cube is x cube. X is the side, right? X is the side or edge. And what is the surface area of a cube? Surface area of cube is 6 into x square. Again, these formulas are important to remember. Now, what is that we have to find? When the edge is 5 centimeter, that means x is 5 centimeter. We'll have to figure out. And edge of the variable cube is increasing at the rate of 10 centimeter per second. Edge of the cube, that means x. Edge is nothing but x. X is increasing at the rate of 10 centimeter per second, which means dx with respect to time, because there is time given here, right? Dx by dt is 10 centimeter per second. This is dx by dt. Now, how fast is the volume increasing and how fast is surface area increasing? So what should we find out? We'll have to find out how fast is volume increasing. That means we have to find dv by dt, right? How fast? Fast means time. So dv by dt. Then how fast is surface area increasing? That means dA by dt. We need to find this. Let's start with dv by dt. dv by dt is equal to, we'll have to differentiate this, right? Because this is the formula for volume. D by, instead of v, we put x cube. We'll have to differentiate this. Now, what is derivative of x cube? It is 3 into x square. And then we'll have to put dx by dt. Let's not forget this. Very important. We are supposed to be differentiating with respect to t, but there is no t here. We are differentiating x, right? We are differentiating x. That's why we'll have to put dx by dt. If it was something like this, say if it was t cube, right? Then we will simply say 3 into t square. But since we are differentiating x cube with respect to dt, it will be 3 into x square and we'll put dx by dt. We know what is dx by dt. Dx by dt is 10 centimeter per second. Let's substitute into 10 centimeter, which is nothing but 30x square. They have given x is 5 centimeter, right? We have to find how fast the volume is increasing when the edge is 5 centimeter. Edge is x is 5 centimeter. So when x is equal to 5 centimeter, dv by dt is equal to 30x square. 30 into, instead of x I'll put 5 square. So I'll get 750 centimeter cube. Why cube? Because it's volume. Volume is always in cube and with respect to time. Now, let's go to second part of the problem. Second part of the problem is you have to find the change in surface area, right? So we found out this one. We'll have to find dA by dt now. dA by dt. What is the formula for area? 6x square. 6x square is the formula for area of cube. So it is 6x square by dt. Now again, derivative of x square is 2x into dx by dt, right? We are differentiating with respect to t. 12x into dx by dt. Now we know dx by dt, right? Dx by dt is 10. Dx by dt is 10. Let's substitute. So 12x into 10, which is 120x. Now what next? We'll have to find when x is equal to 5 centimeter. We'll have to find dA by dt. So dA by dt is equal to 120x. That is 120 into 5. That is 600. This is surface area. Surface area will always be in square. 600 centimeter square per second. Let's take another example where a ladder of 50 feet long leans against a smooth vertical wall. So there is a ladder. So let's assume this is the wall. There is a ladder. So here we have the wall. This is the ladder which is leaning on the wall. Then we have the ground, right? The ladder is 15 feet long. This is 15 feet. So ladder is 15 feet long. If the top slides downwards, top of the ladder starts sliding downwards. That means it is sliding here. This is the top. It is sliding. That means slowly coming down. Now if this is sliding down, that means this will extend, right? If you're pulling this downwards, this will increase. right? It'll extend further on the ground, right? So if that increase, now let's call this as x, this as y, right? Let's call this as, this height is x and this is y, this distance is y. If the top slides downwards, that is, if the ladder starts sliding downwards at the rate of 2 feet per second, now we'll say at the rate of 2 feet, that is x, right? It is sliding downwards. X is the height. So it will be dx by, at the time, second, so it's time, dx by dt is 2 feet per second. Find how fast the lower end is moving. This is the top. This is the lower end. How fast is lower end moving? Obviously, it will move this side, right? As this slides downwards, this will move to the right side. How fast is this moving when lower end is 12 feet away? That is, when this lower end is 12 feet away from the wall, right? From the wall, this lower end is 12 feet away, right? This is 12 feet away. That means y is 12 feet. Y is 12 feet. Now, what is that we have to find? Ladder of 15 feet long. Okay, this is 15 feet. Let's call this as, say, Z. Right? So, we'll say Z is 15 feet. So, now what we'll have to do is, we'll have to find out how fast the lower end is moving. How fast lower end? Lower end is this one, y coordinate. How fast is the y coordinate moving? So, you'll have to find dy. How fast? So, time, dy by dt. This is what we need to find ultimately. We need to get the formula for y. That's how we can find dy by dt. Now, we'll have to use Pythagoras. If you notice, this is a right angle triangle, right? This is a right angle triangle. What is the formula for right angle triangle? It's a Pythagoras theorem. Hypotenuse square is equal to length square plus breadth square, or you can call it as, hypotenuse in this case is this one, side opposite to right angle. Which is the side opposite to right angle? This one, the ladder. We call it z, right? Let's call it as z square. Length x square, right? X square plus breadth is y square. Basically the other two sides, side 1 and side 2. Now z square is equal to x square plus y square. Instead of z we have 15 feet. We know it is 15 square. Instead of x square, we don't know the height of the wall, so we leave it like that. Do we know y square? Yes, 12 feet. It's given, right? 12 feet away from the wall. So this y is 12. So 12 square. So this is nothing but x square is equal to, we will have to find out x square now. X square is equal to 15 square minus 12 square, which is nothing but 225 minus 144. So therefore x is equal to root of 225 minus 144 is root of 81, which is 9. X is equal to 9. We know x is equal to 9. Now I'll have to find dy by dt, right? Now that means I'll have to use this formula, dy by dt. X square plus y square is equal to z square. I'll have to differentiate this. Differentiate on both sides. Only if I differentiate, I'll get dy by dt, right? To get dy by dt, I have to differentiate with respect to t. Derivative of x square is 2x into dx by dt. Let's not forget, because we are differentiate with respect to t, right? Not x. So dx by dt. Derivative of y square is 2y. Again, differentiating with respect to t. So dy by dt is equal to z square. Z square is, we know the value of z square. Z is 15 square, right? This z is 15. Z is 15. So 15 square, which is nothing but 225, right? And what is derivative of 225? This is actually x square plus y square is equal to 15 square. What is derivative of a number? It is 0, right? So now 2 into what is x? X is 9. We got that. That's why we did this entire thing, so that we could get the value of x. X is 9. dx by dt is 2 feet per second. 2 plus 2 into y. What is y? Y is 12 feet. dy by dt, this is what we need to find out, right? So dy by dt is equal to, let's find out this, 36 minus 36 by 24, which is minus 3 by 2 feet per second. We need to figure out how fast. So t, seconds. Y, feet. Y is nothing but distance, length. Y is nothing but distance or length. Unit is in feet, right? So feet per second. So this is the answer. With this, we have come to the end of this particular topic. If you have liked this video, do press a like and share it. Thank you.